Today we're looking at lesson 1-4 on angle measure. So the first part we're going to just talk about the different parts of angles. So this is called a ray. It's going to be a side of an angle. There's certain ways to label a ray, and I've listed those at the bottom here. You can write out the word ray, or you can do a symbol that looks like that with one arrow pointing in one direction. So I've noticed that I've listed MP, and then I've listed MP again a different way. You can also do that with MO. You can do both MO with the word ray, and you can do it with the symbol for ray. But notice that I'm putting that you cannot do OM or ray OM because O is not the end point. So when you're labeling a ray, you have to include the end point as your first letter. The end point in this case is M. Here is just a picture of two opposite rays, meaning they're going in infinite directions, the opposite directions. So you have JH, which would be going this way, and JK, which would be going this way. So those are considered opposite rays. Here we have the parts of an angle. When you have the parts, each side of an angle is considered a ray, so you can label it as a ray. The middle point of the angle is known as the vertex, so in this case vertex X is what we would say. The angle itself, if we're going to name the angle, you either can name it by saying angle 3, because there's the number 3 where the vertex is, or you would need to name the angle with the vertex as the center letter. So you would have to use 3 letters naming the angle, and you'd have X as your center. So you could say angle YXZ, or ZXY, or angle 3. Those are the 3 ways to label this angle. And then we have what's part of the interior of the angle, which is in between the 2 rays, and then the exterior, which would be on the outside of the angle. So if the angle is angle OMN, which is here, the points that are inside the angle would be S and R, and we call those interior, and then the points outside of the angle are P and O, and those would be considered exterior. Now we're going to find different parts of the angles here. So it says, looking at this picture, we're going to find the vertex of angle 5. So if we find angle 5, it's here. Let me circle it. So angle 5, the vertex of that would have to be C. So point C. The sides of angle 5, if we're again focusing on 5, you have the side JG, C there, and A, B, C. So if I'm going to list the sides, I could say JC or GC. Label it as a ray, and then the other side would be BC or AC, and again label it as a ray. And then another name for angle ECL, that's going to be right here if we look. So ECL, like this. If we're going to name it besides ECL, we would need to look at the letter there, or the number, I'm sorry, where the vertex is, which is number 4. So we're going to label it as angle 4. That's another name for ECL. And then the last question is up here, the point in the exterior of angle CLH. So if we erase all this, CLH is going to be here. So a point in the exterior would have to be anywhere that is, if we extend our rays, that is over here. So you could either be D or D or E. Point D or point E. And then we're going to look here at how to line an angle up. Notice that they've put the angle vertex at the center of the protractor. And then wherever one of the lines or one of the sides aligns with the 0, so if you look here, that would be right here. This side aligns with the 0, and that's going to be the 0 on the inside of the protractor, because there's the 0 through 180 on the outside, which is here, and then 0 through 180 on the inside, which is here. So whatever the side is lined up with, whatever side is lined up with the 0, you're going to go with that scale. So in this case, the 0 is lined up with the inner part of the protractor, so I'm going to go with the inner labels of the protractor, so not this one. And you can see that the other line, or the other side of this angle, goes through 50. So I would say that this angle is 50 degrees. There's 3 types of angles. You have a right angle, which is 90 degrees. You have an acute angle, which is going to be less than 90 degrees. A lot of times you'll see, let's name this angle angle 3. So angle 3 is less than 90 degrees. And then you'll see that the angle symbol kind of looks like the less than symbol, so don't get confused there. And then an obtuse angle, if we're going to name this one also angle 3 here is going to have to be less than 180, because 180 is called a straight angle, or greater than 90. And that will be considered obtuse. And then now we're going to look at the different parts of these angles. So it's asking you what type of angles these are. So right, obtuse, acute. And so if we look at AB or AFB, that's here. If we're going to tell what type of angle that is, notice that it looks like it's under 90 degrees. So this is going to be acute. CFA is here. And notice that is labeled with the right angle, so that's going to be a right angle. And the right angle symbol is right here. So we can assume that each side of that angle is right. Then you have AFD. AFD is going to be AFD. That looks like it's going to be greater than 90, so that's going to be an obtuse angle. And then CFD, if we look at that one, that is here. And again, that looks under 90, so that's going to be acute. Now, the book also asks you to measure these, but since we're doing the video, I'm going to have you measure these in class the next day. We're going to practice measuring angles, so don't worry about that step here. And the last part is about angle bisectors, which we talked about the word bisect today in class. Bisect means to split into equal parts. So an angle bisector is going to split an angle into 2 equal parts, as you can see here. So the angle bisector in this case is a ray. We'd label it as WY or YW, and that would be, I'm sorry, not WY. YW would have to be it, because we have to use our end point as our first letter in the ray, so YW. And in this case, it's telling us, and if you look over here, this is what it tells us about the picture. It says KN bisects, so right here, bisects angle JKL, which is here. So if it bisects the angle, that means the two parts that are equal are here. So it gives us that JKL, which is the whole thing, is going to be 9y plus 15. JKN, which is this part, is 5y plus 2. We're going to find JKL. Now, since the angle bisector KN bisects it, that makes this side of the angle also 5y plus 2. And if we know that those two add up to equal the total, which is 9y plus 15, that's how you're going to solve for y. So let's set that up. Okay, so we're going to put these 5y plus 2 plus 5y plus 2 equals to the total angle 9y plus 15. Solve for y, so we need to combine like terms. And then continue to combine like terms. And now we need to get the y by itself. So y would be 11. Now that's not my answer. My answer needs to be the measure of angle JKL. So I would just plug y is 11 into this expression here. So 9y plus 15. So if y is 11, we plug it into 9y plus 15. JKL is going to be 99 plus 15, or 114. And that's degrees, because that's an angle. That concludes lesson 1-4 for geometry in angle measures.